Hi everyone. Hi to all the listeners of my presentation. So welcome and thank you for attending this presentation. Today I'll be discussing about my research which I've conducted on cyber forensic detection of forged image. It's a multi-model approach. So this is highly relevant in today's world because we have an increase in cybercrime and synthetic medias, and this has also I'll be walking through different concept of the literature which I've gone through, architecture and the methodology, evaluation, and forensic case studies which I've conducted on this one. Coming to the abstract. So the abstract captures the core problem, that is the manipulated image threaten the cybersecurity by undermining the trust in digital evidences. So it has become a main problem where this evidence is being kept under question mark. So traditional detectors lack robustness and interpretability. So this research addresses the gap through multimodal fusion and attempt weighing by resulting in a forensic graded detection system. So the main motivation which comes is in the cybersecurity operation, manipulated images can be weaponized. For example, fake screenshots can be used to frame individuals, and then many images can be used for public opinions, like in platforms to Facebook, Twitter, and other multi social medias. So this has turned out to be destroying many of the clues, and also forensic tools are also being finding it hard to detect such kind of fake images. So therefore, a tool must evolve. And they need to automate so that it becomes easier for other people to find if it's fake or how credibility is there for that an image. So the main problem statement, a system can rely on RGB pixels and cannot detect frequency anomalies. So the existing model was only relying on one kind of on a single module. But here I would like to address a multi-model. So the multi-model is where it aims on four forensic maps which are currently legally it can be used in today's world. So, so the multi-model, so the research's main aim is to create a multi-model deep learning architecture that integrate four forensic modules with adaptivity, attention, futures, and it also helps in improving accuracy, robustness, and forensic interpretability over traditional single modularity tampering detectors. So I've also gone through the past recent papers of the few years, and it is depicted that there were multiple researches going on this field, and I think um, there are researches being conducted individually in single modules, but coming to it is time consuming, as well as they are recompressing and resizing the image, so the credibility is lacking. So and also single module are only depending upon the RGB content and not the entire module as such. So this research is having all the four forensic traces components such as RGB, ELA, reducer, and DTC forensic maps. So which I'll be talking in detail about them. So in simple terms, RGB is a red, green, blue that is used to visualize the raw visuals of the image and will help to know if there are any mm, um, noises added to that image. So, so talking more about the RGB, an image may have perfect RGB consistency, if it is having some noise pattern, then the the trueness of the image is questionable. So, so that is one thing. So talking about the multi-model approach, the forensic modularity such as RGB, error, level analysis, and noise reducible (TTC) are kept into mind. So basically, RGB is the most natural modularity as it is directly presents the visual content. So deep networks detects unnatural textures, sharp boundaries, or semantic inconsistency, and will help. And RGB is weak in low quality JPG and can be fooled by deep fake artifacts. So coming to ELA, so it works by recompressing the image and subtracting the references. So that's where ELA is used to find over the different compression signature than the surrounding images of an image. So that will also help in identifying the fake images. And then comes the noise residual. So this detects the disruptions to a like if where the origin like how many images are there, like each camera, um, whether the image was captured in one device or in multiple devices. So that will be known through the noise residual thing. And ETC is captures the subtle changes in the frequency patterns that humans cannot see. So these are the four main approaches which are kept into consideration. So coming to the architecture diagram. So this is the architecture diagram where we have the image being loaded and it is being sent to all for processing, and that will be um, and it goes through its own CNN encoders, and this allows the network to learn forensic specific pattern without contamination from each other modules. And then this is being um, put to a attention fusion module that stacks the 4 vector into a 4 into 128 tensor, and it passes through small neural networks to produce the weight. So softmax is being used to weigh the sum to 1, and then the classifiers are used to identify um, if it is a fully fake image or if it is a forged image. And then the training strategy, I'll be explaining more about them when I'll be walking through the code. So far this is the system architecture. So I'll be walking over the code review now. So coming to the code view, so this is the code setup. This is how the folder is being organized. So the contents are being set up like this. Inside there's a template which is the web application, and then the training data sets are set here. Requirement is whatever installation purpose is required is kept under this file. So samples are the data set are the samples which are used for the testing purpose. So this is how the data has been the data from the training is being split and stored across. So that is the overall structure of the file which I've used. So coming to the code, this is the entire, mm, this block helped to set the environment to load the images, process them, and apply forensic technique. So this also helps to train the module, evaluate them, and generate visual numeric forensic evidence. So that entire base is being set up over here. So So I've also used the hash lab for the hashing function. Yeah, so this eliminates the random in the ML experiments. So ensures the behavior in the So this piece of code is set to eliminates the random in machine learning experiments. So that is why this helps to take the best GPU or CPU or whatever best available device is there for execution, that is over here. And then moving on to the next part is where the directories is being stored. This defines the main directory where the data is stored. Inside this directory, all the images for training, validation, testing, everything is being kept. So, and then here the splicing is being done. So, um, so that is over here. And then here the image resolution part is being done, where the image is being reset to 256 into 256, like which is a common size what is being used for the forensics. So that part has been done over here. So coming over here, the error level analysis. This also helps to load the data that has been done here, and here the testing, training, validation has been done where it is splitted into all the modules. So this is the main function which is being done. So ELA is used to classify forensic technique that are used to detect image tampering by checking the JPG compression artifacts. So the image is being converted to using NumPy, and it will be stored in JPG quality of 90. So that will be done, and then it is artificially recompressed, the compressing the image, and then any forge will be any forge, any inconsistency will be shown over here. So this helps to detect the tampering in splicing, copy paste, or object insertion, etc. over this part. So um, so this can be seen by the heat maps, which I'll be showing by the end of the code. So then comes the noise reducer and the photo response non-uniformity thing. So every camera leaves its own unique pattern. So this helps to identify if that one image has been taken from a single module or a single device, or it is taken from a multiple. So that part has been analyzed over here. Then coming to the third part, so the grayscaling. It is like a Laplacian. The the image has been converted to the grayscale, and it is repeated across all channels. So this will help to know how many, like if there are any noises or if anything extra added to the image, that will be identified over this part. So all these three processes are admissible in the code because they can be uniquely linked to a camera, or inconsistency in the image if they are like having multiple objects added can be identified over this step. So these three are the main forensic thing, and this forensic data set is a custom PyTouch data set designed for cyber forensic image detection. So it loads the image and it performs like abstraction, apply augmentations, and compute multiple forensic features, which I had explained in the above. So the class is being initialized over here, and then the path is being resized to 256 into 256. Like it is for training stability. So augment has been applied if it is true. The uh, applied. So if it is true, then apply data augmentation to increase the model boostness. So that has been done over here. So the data set length is also set over here. The entire those part has been done over here. So the image is being so this is where the Flask has been set to run, and so this is where the Flask has been called off, and this is done inside a environment called Venv, which is isolated environment for the purpose of experimenting. So application will be launched over here, and this is the IP address of this. I'll be calling that over here. So this is where the IP looks like. So a forensic user can upload the image and analyze them. So that will let the user know if the image has been fake, forged, or and it will also help the user to download. This also has the hash functions, the SHA and the MD5 functions of the image, also along with the time, everything. And this is downloaded. So this zip file will be stored and will be having a report, forensic report about the how severe the risk meter, modularity, and anomaly chart of the images, and a JSON file which has the functions over this one. So this will be the ultimate result for being produced in for a cyber forensic expert.